Naples, in an unspecified year of our near future. An abrupt tremor announces to the entire Mediterranean basin that the giant is preparing to erupt. Thuds and bangs from within the earth resonate along the coastal Campania, first agitating the wildlife and then the local inhabitants. After a few days, a white cauliflower-shaped cloud bursts from the Phlegraean Fields, eventually reaching over 50 kilometers in height, with an impressive spread. From Naples, terrifying flashes and lightning can be seen within the black plumes that envelop the massive white cumuliform cloud. The tremors increase in number, frequency, and magnitude, and the vibrations affect not only the ground but also, strangely enough, the air. Typically, eruptions can trigger this kind of effect, but in this case, the trembling air extends hundreds of kilometers away. At that point, the thuds and bangs become louder and more frightening, and no living being capable of moving remains near the Phlegraean Fields. For days, these phenomena repeat regularly, with sudden and unpredictable pauses and accelerations. Large fractures begin to open in the ground, cracks kilometers long that reach the Apennine chain and disrupt small towns. The inhabitants are evacuated, thanks to evacuation plans, just before the ground fissures transform the landscape and the entire region begins to rise significantly. Like a gigantic tumor, the hot plume beneath the Phlegraean Fields lifts the Earth's crust for kilometers around. Suddenly, the now completely black cloud collapses and spreads all around, crashing down on the region. Scorching flows over 500 degrees and incredibly fast, hundreds of kilometers per hour, sweep through the valleys and flatten the surrounding hills. A kind of scorching aerosol loaded with ashes, lapilli, and still semi-molten rock blocks rushes like a burning avalanche, erasing all forms of life. The lighter ashes disperse into the atmosphere and begin to fall on the roofs of nearby cities and then on those further away, like Caserta and Salerno. Events escalate, this time heralded by the birth of thousands of new, extremely hot fumaroles, dotting a region of tens of square kilometers. The renewed column of eruptive clouds is fed impressively and reaches the incredible height of 100 kilometers. Ash falls everywhere, accentuating a gray and menacing darkness in the sky. At that point, the explosion occurs. The detonation is felt throughout the northern hemisphere, a roar beyond the common experience of living beings, followed by a massive air displacement like never before. An airquake that circles the globe several times, in London, as in Paris, in Moscow, as in Istanbul, everyone feels, in the literal sense of the word, that something terrifying has happened. Simultaneously with the explosion, the so-called base surge begins, a true physical wave that ripples the ground as if it were liquid and moves everything in its path. This phenomenon has been known to humans since the time of underground nuclear tests, and to geologists who study those particular volcanoes whose eruptions occur in the presence of groundwater, lakes, or the sea. Here too, the water-magma interaction amplifies the explosion's violence by dozens of times, making it incomparable to any man-made phenomena, not even hundreds of atomic bombs exploding simultaneously. A storm of scorching stones, lapilli, and ashes darken the sky over all of central Italy, forcing city inhabitants to evacuate. Burning clouds, now more correctly called pyroclastic flows, develop for weeks, fortunately enough to evacuate an impressive amount of magma. Airports close and road traffic becomes impossible due to the thick ash rain. Life comes to a halt. The economic, social, and political repercussions are enormous. No citizen wants to leave capital and banks or securities. Like in Pompeii 2,000 years ago, people want to hold onto their possessions, fearing they might have to leave their countries. Meanwhile, the landscape has become a desert of ashes and lapilli, where the washing waters of incessant rains begin to act. Massive mudflows rage for months throughout Campania, burning everything. It's hell. So if it happens, things will surely go as we have described. For now, however, the giant sleeps, half buried between sea and land. Occasionally it stirs and makes everything tremble, but then everything calms down. But as you will understand in the continuation of the spectacular video, as always prepared for you by the Insane Curiosity channel, The fact that the volcano has long refrained from following through on its threats should not make us feel safe. The clock of the Phlegraean Fields continues to tick, and if the bomb goes off, it will be a disaster for Italy and the entire world. Okay, friends, the description with which we open this video is just a fictional reconstruction of what could happen in one of the most beautiful and historically rich places in the world. We are talking about the Phlegraean Fields, the region of the universe where, as the French Baroness Madame de Staël wrote, volcanoes, history, and poetry have left the most traces. A fascinating and mysterious region that, over the centuries, has been the backdrop for ancient myths and legends. The gateway to Hades, according to the Greeks and Romans, so much so that it is here that Virgil, in his Aeneid, begins Aeneas' descent into the underworld. A patch of land dotted with lavish patrician and imperial residences, thermal baths, piers, villas, fish ponds for breeding oysters and moray eels, and an imposing amphitheater, the third largest of the Roman era in Italy after the Colosseum and the one in Capua. But if the giant seems to be sleeping, sometimes when it changes position, it does so a bit too abruptly. And then, even without reaching the worst-case scenario, the consequences of these upheavals in the Naples and Pozzuoli area can turn into seismic movements of considerable intensity. Just as been happening in recent months, with the volcano responsible for the largest seismic swarm in the last 40 years, with 150 earthquakes shaking the region in southern Italy on the evening of May 20th. The swarm included a magnitude 4.4 earthquake recorded at a depth of 1.6 miles or 2.5 kilometers below the surface and lasted almost 5 hours, causing panic among residents in the Naples and Pozzuoli region. Since last autumn, the seismic activity of the volcano has increased significantly, with continuous tremors, some stronger than magnitude 4 on the Richter scale. Even more worrying is the behavior of the ground in the same area, which has risen by an average of about 15 millimeters per month since the beginning of the year. The inhabitants of this area, especially those of Pozzuoli, have been forced to live with bradysism for centuries, the volcanic breath caused by cycles of ground uplift and subsidence due to the rise of magmatic fluids. This type of seismic agitation has occurred several times in the last 50 years in the Phlegraean Fields. In particular, from 2005 to today, the center of the caldera has risen by 98 centimeters. And this is decidedly worrying because in some cases, ground uplift can indeed be a precursor to an eruption, as in the case of the last eruption of the Phlegraean Fields in 1538. However, it should be considered that between 1970 and 1972, and between 1982 and 1984, the surface of the Phlegraean Fields rose by about 3.5 meters or 11.5 feet, and no eruption occurred, only significant seismic activity. Therefore, ground uplift is not the only parameter that must be considered to understand the normal state of a volcano, but rather it is the combination of geochemical, seismic, deformation, gravimetric, and other indicators that allow us to predict the future behavior of the volcano. Before moving on, don't forget to subscribe to the channel if you haven't already. Make sure to hit the notification bell so you don't miss out on our daily videos. The caldera began to show increased activity in the 1960s after a relative calm that lasted for centuries. Large-scale evacuations of Pozzuoli already took place in 1983, when a series of earthquakes and a ground uplift of 3 meters or 10 feet suggested that an eruption might be imminent. But then nothing happened. There was another vigorous seismic swarm in 2012, but this too did not directly lead to any new eruption. In short, the Phlegraean Fields, a Latin toponym we can translate as flaming fields, can be described as a large volcanic area located in the Gulf of Pozzuoli, northwest of the city of Naples. The area, seen from above, shows a very particular morphology. There is no single volcanic edifice dominating the landscape, as in the case of Vesuvius, Etna, and all the most famous volcanoes, but it is characterized by the presence of a huge caldera 15 kilometers in diameter, dotted with dozens of generally low volcanic cones. In most cases, these volcanoes are monogenetic, meaning they are produced by a single explosive eruptive activity. The Phlegraean Fields, which cover an area of 450 square kilometers, are a must-see tourist destination for those visiting Naples, but they are also a nightmare for the inhabitants forced to live with a kind of capricious monster, and they are especially a geological puzzle for those involved in land management. The Phlegraean Fields indeed represent a challenge in terms of monitoring and deciphering hazards. Imagine transferring the Yellowstone caldera from its original, practically uninhabited location to the outskirts of Houston or Phoenix, that is, to a densely populated area. It is evident that in the new situation, even the slightest changes in seismic activity, gas emissions, or ground deformations should be monitored much more carefully, aware that any minor error in predictions could cost the lives of hundreds of thousands of people. Just think that 485 years have passed since the last eruption in the Phlegraean Fields, and as you can imagine, much has changed since then. In 1538, the population of Naples and its surroundings was a few 100,000 people. Today, that number is closer to 3 million people. With the increasing unrest between the Phlegraean Fields, Naples must reckon with the fact that even a small eruption, like that of 1538, which affected only a small part of the caldera, could require the evacuation of at least 1 million people from a densely populated area. But after all of southern Italy is actually a crucible of lava. Lava that flows both from towering surface volcanoes and those hidden in the depths of the sea. Vesuvius, Etna, the island of Volcano, the island of Stromboli, Marsili, the largest underwater volcano in Europe, active. You know them, right? In short, the center of the Mediterranean lives and thrives literally above a sea of boiling magma, a condition certified by the disastrous earthquakes that continue to occur in this region of Europe over time. Wait a minute though. So far we have talked about the Phlegraean Fields, almost assuming that you are all already aware of the history of this territory and its characteristics. But in reality, what are we describing? The Phlegraean Fields are actually an ancient volcano with particular morphological characteristics, so much so that it is defined, perhaps wrongly as we will see shortly, as a supervolcano, on par with Lake Toba in Indonesia, the Yellowstone caldera in the USA, and the Anyakchak caldera in Alaska. It does not have a mountain that identifies it, but a caldera precisely. That is a gigantic mount that exploded 39,000 years ago, erupting something like 70 cubic kilometers of lava materials. Vesuvius, when it buried Pompeii, erupted only 8, up to 38 kilometers in height, a deadly cloud that then spread to cover half of the peninsula, the Balkans and Central Europe up to the Ukraine and the Urals. If the Phlegraean Fields were to erupt, one can only imagine the scale of the disaster. For decades, the area has been used for urban expansion, and despite the warning signs of danger, there are at least a dozen small active volcanoes in the fields, the most famous being the Solfatara. The area is densely populated with about 3.5 million people, all exposed to disaster, as the caldera extends to the southwestern part of Naples, Bagnoli, Pozzuoli, and the entire bay up to Ischia. It has been calculated that a potential phreatic explosion, a mix of water and lava, would see Italy split in half, and due to air currents, the central, northern part would be most affected, with a pyroclastic cloud 1.5 kilometers high, invading all of Campania, Lazio, Abruzzo, Marche, Tuscany, and Emilia, partially scaling the Apennines. It would then cross the Adriatic towards the Balkans at a speed of 500 kilometers per hour, leaving behind only ash, destined to compact up to 100 meters thick, the so-called yellow tuff, which is found today from Campania to Calabria. It would probably be the end of the Italian peninsula and a heavy blow to the European continent as well. How the caldera formed. But what exactly characterizes the area we refer today as the Phlegraean Fields? Certainly the caldera. A caldera forms following the collapse of part of a volcanic edifice into the magma chamber once it has emptied of its internal magma. What causes the volcano to collapse is the emptying of the magma chamber, which, due to the decreased pressure after the eruption, can no longer support the entire volcanic edifice. In subsequent epochs, when the volcano becomes active again, it begins to rebuild the volcanic edifice within the caldera. The term caldera is often confused with that of a crater, which in the strict sense is the circular depression with a diameter of a few hundred meters at the top of a volcanic cone. There are also rare cases of non-volcanic calderas created solely by erosive events. In the specific case of the Phlegraean Fields, it is a structure linked to two major caldera collapses that occurred 39,000 and 15,000 years ago, that is, formed during two large explosive eruptions of high energy. Caldera is a term that in Spanish also means pan and refers precisely to the typical pan used to prepare paella, wide and with very low edges. The Phlegraean Fields have exactly this structure, a collapsed structure whose limits range from the Pozzuoli hill to Monte di Prosidia, with a rim that is two-thirds submerged in the Gulf of Pozzuoli. It is a very characteristic area, unmistakable even from aerial photos, with a circular structure pitted inside by various volcanic craters. North of Pozzuoli is the Solfatara, an active crater where powerful fumaroles erupt their sulfurous vapors at over 160 degrees Celsius, while in a central depression of the caldera, boiling mud can be observed at 140 degrees Celsius. A truly infernal scenario, all the more frightening when one considers that the mechanism driving this spectacle is the monster lurking underground, a pulsating and living creature that could, at any moment, transform into a true supervolcano. Supervolcano? Really? Let's say that this is not actually a volcanological term. It was invented to emphasize the power of an American volcano around the 1940s, then fell out of use. More recently, around 2000, the BBC made a documentary about supervolcanoes, focusing on Yellowstone, bringing the term back into the spotlight. In reality, from a geological point of view, the supervolcano does not exist. At most, there can be a super eruption of a volcano, but this adjective is mainly used in journalism. In volcanology, super eruptions are those with a volcanic explosivity index (VEI) of 8. Highly explosive eruptions generally classified as catastrophic. Yellowstone has historically had such eruptions, but it should be noted that even these so-called supervolcanoes most often produce much more modest eruptions. The most violent eruption of the Phlegraean Fields 39,000 years ago was classified with a VEI of 7. However, this eruption, like other major volcanic events, had a very significant impact on the environment. The large amount of particles and gases emitted in these cases, particularly sulfur interacting with the atmosphere, causes a certain reflection of the sun's rays, resulting in a cooling of the atmospheric pressure for a certain period. With that eruption, the Phlegraean Fields indeed caused a change in the climate of the northern hemisphere, with a temperature decrease of at least 3 to 4 degrees. And it is not an exaggeration to say that this change was responsible for the disappearance of the last Neanderthals. But what type of volcanism characterizes this area? The reconstruction of the eruptive history of the Phlegraean Fields tells us that this volcano tends to produce explosive eruptions, preferably of medium and small size, with very rare effusive eruptions. Just think that in the last 15,000 years there have been more than 70 eruptions, and of these only 4 have been effusive. Effusive eruptions are those in which magma is quietly expelled from the volcano in the form of lava flows. Today we have a good example of this in the eruptions of shield volcanoes of Hawaii. As for the major ones, these are eruptions that have had a significant impact on the territory on which construction and reconstruction have taken place. In Naples, for example, just look around to realize that many of the city's buildings and monuments are built in yellow tuff and gray tuff, which are among the main products of the Phlegraean eruptions. This type of volcanism has undergone variations over time, being gradually influenced by the structural evolution of the caldera, which by changing shape has modified the speed of magma ascent to the surface. In particular, in the last 10,000 years, it has been observed that the bottom of the caldera has begun to have resurgent movements due to changes in the structural response of the caldera floor. All this fits into what is the extremely peculiar geological phenomena for the area, bradyseism. The name, I realize I haven't mentioned it yet, comes from Greek and can be translated as slow earthquake, indicating a very slow ground movement, characterized by an uplift followed by a much smaller subsidence. This phenomenon is linked to forces coming from slightly deeper parts of the crust, due to the rise of magma or the injection of hotter and deeper gases that expand the geothermal system lying beneath the Phlegraean Fields, evident in the manifestations at the Solfatara. But perhaps we are explaining things with too technical terms here, delving into details that might be unclear to those who are not in the field or who have never visited Pozzuoli. In the end, we believe the question everyone wants a quick answer to is this: what is the current state of the volcano? Is there a real danger of an imminent eruption? Well, let's say right away that the matter is very controversial. Currently, the caldera is in a state of quiescence. This means there is no eruptive activity, but there is background volcanic, seismic, and deformative activity. Moreover, since December 2012, the Phlegraean Fields have risen in alert level from green, base, to yellow, attention, precisely because of the variations in seismic, deformative, and geochemical parameters that have indicated an evolving trend for about 10 years. A new study published in June in Nature's Communications, Earth and Environment warns of the explosive potential of the Phlegraean Fields. The study argues that the volcano's activity since 1950 and its weakened crust are evidence that the caldera's crust could be close to breaking point, which could lead to a phreatic eruption. The researchers also warn that because the volcano is in a structurally weaker state, magma could more easily move to the surface, which would not trigger the typical warning signs of high seismic activity and ground uplift. The authors cite the unexpected eruption of the Rabaul caldera in Papua New Guinea in 1994 to conclude that past behavior cannot be relied upon to predict eruptions of large calderas. However, this does not mean that the alert level must necessarily change to orange, pre-alarm, and then to red, alarm, in the future. Over time, the parameters could return to more stable values, and the alert could therefore be downgraded. These variations in alert levels can also have very long time scales. The yellow alert level should remind us that the Phlegraean Fields are indeed in a state of quiescence, but it is not the same deep quiescence as, for example, Vesuvius. After the recent tremors, rumors have started circulating again that if the supervolcano blew, it would drag Vesuvius with it. But the chances of that happening are considered very slim. And here's why. Not all volcanoes are the same. The first simple consideration is purely geographical. The Phlegraean Fields are about 30 kilometers away from Vesuvius. What further separates the Phlegraean Fields and Vesuvius is their structure. Vesuvius is a stratovolcano, a typical volcano, the kind everyone imagines with an eruptive cone. In the case of Vesuvius, there are actually two, Monte Somma and the Great Cone of Vesuvius, with steep slopes and a crater at the summit. The Phlegraean Fields, on the other hand, as mentioned, are a supervolcano, essentially a field of hundreds of square kilometers with dozens of craters opening onto the caldera, sometimes even difficult to identify. They belong to two different families, making a distant entanglement unlikely. Moreover, the Phlegraean Fields and Vesuvius are configured as different entities, even in their volcanic activity. The Somma-Vesuvius volcanic complex is also extremely ancient, but its volcanic activity is different, characterized by four main eruptive phases, the last of which lasted from 1631 to 1944, the year of the volcano's last eruption. Today, Vesuvius is in a state of quiescence with an obstructed conduit, and experts from the National Institute of Geophysics and Volcanology, INGV, do not highlight significant variations in its state of activity, so much so that the alert level of the Vesuvius Observatory remains at green. But it's not just the modes and timings of the eruptions that don't coincide. The material erupted by the two complexes in the past is also different. Geochemical and petrographic studies indicate different minerals and different depths of formation. Most of the evidence, in short, suggests that the Phlegraean Fields and Somma-Vesuvius have two distinct and independent magma chambers that should not influence each other. For completeness of information, however, it should be noted that there is data collected through other investigation methodologies, seismic tests, that seem to identify a common magma chamber between the two volcanic complexes. at a great depth, more than 10 kilometers from the surface. In any case, whether the danger of an explosive eruption is imminent or projected far into the future, the Neapolitans continue to live as usual. Their homes, the railway network, restaurants, schools, hospitals, and historic buildings are nestled between the volcanoes, and there is no sign of residents wanting to abandon their lives, not even in the red zone. It's not that people are unaware of the threat of a future eruption. They simply don't want to think about it. And they continue to consider the Phlegraean Fields as their house cat, to scratch on the head while it purrs reassuringly.